I would like you to remember back to elementary school when you multiplied fractions. So if we had 2/3 times 3/2. When you multiply fractions, you multiply straight across the top, straight across the bottom. So on the top, what is 2 times 3?
6.
And on the bottom, what is 3 times 2? And what is 6 divided by 6? 1. So when you multiply a fraction by its reciprocal, flip the fraction over, your result is 1. The other thing I want you to remember, and this is not from elementary school, if you have something raised to an exponent, and you take that thing and raise it to another exponent, the result is that you multiply the exponents. So if we have an exponent that is a fraction, if we raise both sides to the reciprocal of that fraction, a fraction times its reciprocal ends up being 1. We can eliminate that exponent. That's what we're going to do today. We're going to combine these two skills and get rid of fractional exponents as we're solving. So there are step-by-step instructions at the top of your page. Your first step is isolate the power. So in number 1, I want you to remember that 2x to the 3/2 is not 2x to the 3/2. It is 2 times x to the 3/2. So isolate the power means get that x to the 3/2 by itself. How would we do that? So we would divide both sides by 2. That will give us x to the 3/2 equals 125. Using the strategy that we just talked about, we want to get rid of the fraction of 3/2. We want 3/2 to become a 1. So we are going to raise both sides to the reciprocal of 3/2, which is 2/3. On the left side, you'd multiply those two fractions together, and you don't actually have to do that. You just know that a fraction times its reciprocal is 1, so we now have x, plain old ordinary x. On the right side, we'd grab our handy-dandy calculator and do, if I can get it turned on.
83.3.
That is wrong. All right, 125 raised to the, now depending on your calculator, you may or may not need to use parentheses. I would say even if you have an amazingly smart calculator, use parentheses. Use 2/3 in parentheses. So parentheses 2 divided by 3, close your parentheses. Your answer is 25. Okay, now we need to talk about steps 4 and 5. Steps 4 and 5 are designed to take the guesswork out of this. Really, truly, if you understand what you're doing, you don't need to think about steps 4 and 5 because it'll just be part of your thought process. But if you want to boil it down to step-by-step instructions, step 4, check the solution in the original equation when the denominator of your fraction is even. So go back to our original problem. If the exponent fraction, if the denominator is even, you should check your solution. Now, you should probably just get in the habit of checking your solution all the time, but if the denominator is even, that means it's like a square root or a fourth root that's happening. You need to check your solution, make sure it actually works. So again, this shouldn't be that difficult. You just plug it into your calculator. 2 times 25 raised to the parentheses 3 over 2. Just verify that it does indeed equal 250. Step 5. If the numerator in your original fractional exponent is even, then your answer will need a plus minus. We'll talk about that in example 2 because that actually happens in example 2. All right, example 2. What should we do first in example 2? divide by 3. So we get x to the 4 thirds equals 243 divided by 3 is 81. To undo a fractional exponent of 4 thirds, we raise both sides to the reciprocal 3/4. Okay? Plug that into your calculator. 81 raised to the parentheses, 3 divided by 4, close your parentheses, 27. Okay, step 4 says check the solution in the original equation when the original exponent denominator is even. Our original exponent denominator is not even, so we don't technically have to check this one. But it is a good idea just to check everything, and it doesn't take very long. 3 times 27 raised to the 4 thirds. Just verify that it does indeed equal 243. This is also a way to make sure that you didn't make some crazy mistake in the process of solving. So I did get 243 when I plugged that into my calculator. Step 5, if the numerator of the original fractional exponent is even, then your answer will need a plus minus. So look at our original fraction. See how the numerator is even? So in the process of solving, we raised it to the 3/4, which means we took a 4th root. If that 4 ends up in the denominator, we took the 4th root of both sides in the process of solving, which means we need to put a plus minus in front of our answer. So if you're thinking about what you're doing, when you raise both sides to the 3/4, you should see, oh hey, I'm taking the 4th root of both sides. I need to put a plus minus in here. If that's not what's going on in your head, that's fine. Then you just need to rely on these step-by-step procedures. If the numerator of your original fractional exponent is even, then you must have a plus minus in front of your answer. All right, try number 3 on your own. Go. Okay, step 1, isolate the power. X to the 1/4 equals 4. You divide both sides by 2. Step 2, raise each side to the reciprocal of the power. So we raise both sides to the 4th. That gives us x equals 256. So step 3 up here says simplify and solve for x. I kind of did that in with my step 2. Number 4, is your original denominator even? Yes, it is. So we should check just to make sure. 2 times 256 raised to the 1/4. Make sure that it does indeed equal 8. It does. Number 4, or number 5 actually up there, if the numerator is even, was our original numerator even? No, our original numerator was 1, so we don't have to worry about that plus minus. So our answer is positive 256. All right, number 4, we're going to cross out. Number 5. Okay, step 1, isolate your radical, or isolate your power. It is raised to a half. Okay, so this is the square root of x plus 6. But ignoring that for the moment, is the power isolated? Can we subtract 6 on both sides right now? No. The parentheses is completely locked down with that exponent. Until that exponent is gone, don't touch the insides of the parentheses. So our power is isolated. Our next step is to raise both sides. So we've got x plus 6 to the 1/2 equals x. We need to raise both sides to the reciprocal of 1/2, which is 2. That will give us x plus 6 equals x squared. When you have x squared and x in the same equation, you have to get 0 on one side and factor. So I'm going to subtract x on both sides and subtract 6 on both sides to get 0 equals x squared minus x minus 6. So this step is get equals 0 on one side. The next step is to factor. And once again, if this kind of factoring completely freaks you out and you feel like you have no idea how to do it, come to Wildcat Hour. I will help you. I'll give you like 15 problems in a row super fast and get this stuck in your long-term memory so that you'll never forget it. We are looking for two numbers who multiply to give us -6 and add up to -1. Which numbers do that? -3, +2. Your next step is to solve. You get one side equal to 0, you factor it into binomials, and then you solve. Our solutions are x equals -2 and x equals +3. Now I'm going to take my solutions up here where I have a little bit more room to work. Especially if you get two solutions as your answer, you should check both solutions to see if they actually work. So let's check -2. I'll use red. -2 plus 6 is 4. So if I plug -2 into both of these x's, I get 4 raised to the 1/2 equals -2. If the exponent of 1/2 is given to you, remember an exponent of 1/2 is like a square root. If the square root is given to you, you have to assume the positive root only. Or, this is where your calculators are really, really nice. Check this. 4 raised to the 1/2. Your calculator says it should be +2. So, is -2 one of our solutions? No, it is extraneous. Okay, the question came up, where the heck did you get this 4 to the 1/2 equals -2? What the heck just happened? You go to the original problem before we did anything to it. And we took our solution of -2 and plugged it into this x and this x. -4 plus 6 is, -2 plus 6 is 4, and then -2 right there. Now let's try plugging in 3. 3 plus 6 is 9, so we have 9 raised to the 1/2. And then plug your 3 into the other x. Is 9 raised to the 1/2 equal to 3? Is the square root of 9 3? Yes, so x equals 3 is our solution. They are transitioning the ACT math test to a test that involves a whole lot more reading. So this problem could potentially be an ACT problem. So if word problems currently scare the crap out of you, get over it, put on your big girl panties, and deal with it. So, you work for a company that manufactures Plumb Bobs. Now, do I expect any of you to know what a Plumb Bob is? Some of you actually might know what it is, but most of us are like, what the heck is a freaking Plumb Bob? Okay, a Plumb Bob is a little piece of metal that hangs from a string, and it helps you to level and make things square when you're building. So, a Plumb Bob, it's typically kind of long and skinny. Here's the problem. The same mold is used to cast Plumb Bobs of different sizes. So, it's a tall, skinny mold. If you pour a metal alloy in for like a second, it makes a short Plumb Bob. If you pour in a metal alloy for like 5 seconds, it would make a much taller. They're actually telling us it's only between 0 and 3, but whatever. The equation models the relationship between the height, h, and the Plumb Bob and the time t in seconds the metal alloy is poured into the mold. So here's the equation. How long should you pour the alloy into the mold to cast a Plumb Bob with a height of 2 inches? So 2 equals 1.5 times the cube root of t. So regardless of whether or not you know what a Plumb Bob is or you care what a Plumb Bob is, what they're really saying is, here's an equation. 2 equals 1.5 times the cube root of t. Solve it. What would you do to solve it? Divide by 1.5. What would you do next? Raise both sides to the third. If you don't round it, if you leave that 1.3 repeated in your calculator and then raise it to the third, you end up with 2.37.